All right, welcome back. We are looking at lessons 75 and 76 today. So open your books to page 495, lesson 75, and welcome to geometry. New idea, writing the equation of a circle. So we've talked about linear equations, which is to say equations of lines. And those we know was the form of y equals mx plus b, and that's a linear equation. That's an equation of a line, and it could be, you could say, y equals 3x plus 10. And I'd say, what is that line? And you come over here and say, well, the slope is 3 over 1, so it's rise over run, it's up 3 over 1, up 3 over 1, here to here, but it also crosses the y line at 10. So you come up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go up 3 and over 1. Well, I can't do that. I'll go down 3 and left. 1, 2, 3, and here. Same idea, 1, 2, 3, and here. So this is the line. It's a bad, picked a bad equation, but that would be, that's the line y equals 3x positive 10. Crosses the y line at 10. That's the y-intercept. And it has a slope of 3 over 1. Rise over run. It's a slope of 3, which is 3 over 1. Rise over run, that means it's up 3 and over 1. Linear equations, equations of lines. That's what that is. We're looking at writing the equation of a circle. Now, to analyze a circle on a coordinate plane, it is necessary to derive an equation for the graph of the circle. Simple version of this equation can be found by looking at circles that are centered at the origin. All right, if I draw a circle over here on the coordinate plane, and I draw it centered at 0 and 0, that's the origin, and it has a radius of 1 unit, and it'd be this nice little circle right in the middle, right here, and there it is. After 3 or 4 times around, it still doesn't look like a circle. That's what's drawn in the book, even though it's blown up a little bit and the graph looks like it'd be more than 1. But suppose that point P, which is some unknown point, is a point on the circle with a 1 unit radius. What is the length of QP? And how is QP related to x and y? Well, if you look carefully at the drawing, and you can just pick any point. I'm going to enlarge this circle just to make it easier to see. Let's just pretend that this is still a unit of 1, so this is 1. And I just pick a point on this circle. I'll pick a point on which circle? Pick a point on this circle, and I say, what is this length, and how is it related to x and y, which is this distance over here, how far over, that's x, and this distance, which is y. Well, we know what this distance is. This distance is 1, because that's what the radius of the circle is. And if you look at the x and you look at the y, this becomes a right triangle with a hypotenuse of 1. So if I just take the triangle out of that circle and put it right here, this length is 1, and this is x, and this is y. This is the horizontal distance over and the vertical distance up to get to my point, whatever point I picked. And that was right here. The Pythagorean theorem would then tell us that x squared plus y squared is equal to 1 squared for this triangle. And since 1 squared is 1, you could just say that. X squared plus y squared equals 1. Now what happens if I pick a point on the circle that is, let's say down here, right here. Again, what is this length? That length is 1. Any point on this circle that I pick, the radius is 1, so that is going to be 1. And this distance now, x is bigger. X comes all the way over here. This is the x value. I got to go way over here. 1, 2, 3, 4, 5, 6, 7, whatever. I mean, I'm counting, but I go over here and then I go up. Now y is smaller. So this triangle looks a lot different than this one. This second triangle I drew looks like this. X is here and y is here. This is still 1. We're just on a string rotating around that point. It'll always be 1. This will always be 1 for this circle. And this is still true. For this triangle, x squared plus y squared equals 1. Even though x is bigger than this one, y will be smaller, and it'll stay in that ratio to satisfy the Pythagorean theorem. So this is actually the equation of that circle. X squared plus y squared equals 1. And to generalize, then, for any circle with a radius of r, the equation is x squared plus y squared equals radius squared. And you can see how the radius squared is just another term for c squared. So the Pythagorean theorem, a squared plus b squared is c squared. We named them a squared plus b squared equals c squared, but we just renamed the a and the b as the horizontal distance being x and the vertical distance being y, and then the c squared, the hypotenuse, is the radius of the circle. So Pythagorean theorem right here turns into the equation for a circle, x squared plus y squared equals radius squared. That is for circles that are centered at the origin. That is for circles that have their center point at 0 and 0. Now, we can move that circle and come up with sort of a modified formula or a modified equation of the circle. If we move that circle and we move it up this direction, and we move it over, we increase the y of the center of the circle, so we move it over here. And we say, what is that circle? Well, we still know that this distance, the radius, is still going to be related x squared to this, but we have to account for that movement, and the way we do it is we take this, the way I like to think of it is we take this equation and we pretend like we're backing out of this equation the movement. We're subtracting the movement. So what we do is say x squared, and then if I would, let's just pretend I'm going to move this circle back to 0. That's how I'm going to think about it. So I think, what is the amount? 1, 2, 3, 4, 5, 6, 7. I moved it 7 over to get here. There's a 7-unit movement in the horizontal. So x squared minus 7 plus y squared minus its y movement, which I went 1, 2, 3, 4, 5, 6, 7. I went 7, 7. That's unfortunate. Subtract the 7, the y movement. That will equal radius squared. So it got bigger, it got messier. What I'm doing is I'm subtracting my x movement and I'm subtracting my y movement, and then it's based on this formula. So if you turn the page, you'll find that and I should have went, yeah, I didn't do that right. It's x minus 7 squared. The square has to be at the end once I subtract the movement, so that's maybe really confusing. But I have to move the x, I have to account for the x movement first and then get that number and then square it. So that's going to be, this is the formula. Now I have a 7 in there because that was specific to that circle that I moved right here, 7 and 7. If I want to generalize this formula and make it apply for any circle, then I would have to put other numbers, other variables in here, and they decide to put h and k, which is really dumb, I think, but that's what they do. X minus h, do they put h first? Squared plus y minus k squared equals radius squared. H is the x movement, the x value of the center of the circle. K is the y movement, the y value of the center of the circle. And the reason I went like this and did that is because I like to think of this equation. This equation is the equation of a circle anywhere on the graph. It could apply to the ones in the center. If they're at the center, back to this original one right here, then what is my x movement? My x movement is 0. My x value is 0 for the center of the circle. The x is at 0, and the k is at 0. So then it simplifies back up to this formula. If I change it up to the 7 and 7, my x, this is the center of the circle, where the center of the circle is located. So h is the x value of the center of the circle, and k is the y value of the center of the circle. Hope it makes sense like that. The way I like to think of it again is just, it's this formula, but I'm just backing out the changes, whatever happened to get it from 0 up to where it was, or if it's backwards this way, then it'd be, x minus negative 7 or whatever. You be careful with the signs, but this is the formula. It's like you're taking this formula and just compensating for the change. Subtract the x value of where the new center is, and subtract the y value where the center is. The way that will work is, look at example 2. Writing the equation for the circle from a graph. So this is on page 496, the top of page 496, right underneath the equation of a circle box. Example 2. So there's a circle. A is a point on circle D. Write the equation of circle D. So A is a point at 1 and 0 according to the graph, and the center of the circle is at 1 and 3. 1, 2, 3. So point D, which is the center of the circle, is at 1 and 3. And A is a point on the circle. The question is, what is the radius of that circle? Just count from the graph. Since it's on a graph, you're just observing and you're counting. That is a radius of 3. Then substitute those values into that top equation. So this is the equation, and we said that the center of the circle D was at 1 and 3. So this is your H, and this is your K, and the radius is 3. So just fill this into this equation because that's what it's asking for. It's asking for the equation of the circle D. So for the circle D, the equation is x minus 1 squared plus y minus 3 squared equals 3 squared. And you could decide to fix that and put a 9 on there. That's fine if you want to get rid of that 1 square thing. You're going to have to leave these two squares here because you can't in this case you're not solving necessarily, you're just writing an equation. And what you're doing is saying that for that circle, or the circle D in the book here, the circle D, I could pick a point on that circle, and anywhere on that circle my x and y values would have to satisfy this equation. You could put the x in here and the y, and if you take 1 off of the x squared and take 3 off of the y squared, it would have to equal 9. This is the equation for the circle D in the book there. The second one says circle E is concentric with circle D. This is now example 2b. Concentric means being in the same circle, being in the same center. And it has a radius of 5. So nothing changed about the center of the circle. This stayed the same. And it's simply 5 squared over here. Your radius squared. 5 squared or 25. But 5 squared. All right, now let's go backwards and graph. So graph a circle from the equation. What we did this time was write the equation from a graph. Now let's go from the equation to the graph. So the equation is, this is example 3, the equation of circle P is x squared plus y squared equals 25. X squared plus y squared equals 25. First thing to notice is this formula, the simplified version, which means what is my x and k? 0. 0 and 0. Since there's no other x and k in here, since it's not an expanded version, that tells me that the circle is centered at the origin. So the center of the circle is here, and this says 25, and you have to go, this is radius squared, so you have to find the square root to find the radius. Since this says whatever value is here is radius squared, since it's 25, you have to back it down and say that means the radius is 5, because x squared plus y squared equals radius squared. So the radius is 5 in the circle center of the origin. Just count up 5. 1, 2, 3, 4, 5 right here. 1, 2, 3, 4, 5, and get your compass. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Just estimate, but you put these 5 markers out here and just draw a circle as best you can. And that, just draw one circle. But anyway, that's the graph. Now let's do one that is not centered at the origin and see if we can make sense of that. The second one, which is example 3b, says the equation of circle Q is x minus 2 squared plus y plus 1 squared equals 16. Now, they threw that in there for us to confuse us maybe. But you're going to have to rewrite the equation into the form x minus h squared plus y minus k squared equals radius squared. So one thing you can do is get rid of the 16 and turn it into something squared. So 16, the square root of that is 4, so this becomes 4 squared. That means the radius is 4. I hope that makes sense. Radius squared, if you have a number that doesn't have a square root, then you have to find the square root of that, so you can put a square in it so that you can find the radius, because the radius is this one. Now let's deal with this. This one is fine. That means that h is 2. But what is k? Since here it's y plus 1, we have to rewrite this into a minus k. So the way to get y plus 1, the way to get that would be y minus negative 1. And that may seem confusing, but y minus negative 1 is the same as y plus 1. If you're going to subtract a negative number off of something, it's the same as adding that number. So you're rewriting, you're just trying to find this. In this case, h equals 2, because the minus is already in the formula. So h is 2, and here's your minus in the formula, and the k becomes negative 1. So this is telling you what the center of the circle. The center of the circle is located at 2 and negative 1. So you go over 2, down 1, and your radius we said was 4. And then draw it. 1, 2, 3, 4, counting 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. There's your circle, sort of, and it's best if you have a compass that you're just trying to get there close. And you can go ahead and label this and say this center of the circle is at 2 and negative 1. That's pretty straightforward, except for this little trick here. Since they gave you a positive 1, you have to convert it back into this format where you have y minus something. And for this to be true, it's y minus negative 1. And that is going to be, we're going to stop there. Equation of a circle, it's really two things to remember. And you're just going to have to memorize, maybe just memorize that equation of that circle. This one I think is close enough to the a squared plus b squared equals c squared. We can know that. But this one right here is what you're going to have to memorize. And you can connect it to this one, which is connected to a squared plus b squared equals c squared. The way you connect it is you just remember I'm going to have to subtract my movement. It's just like you're pretending, what would it take to get the circle back to 0 and 0? Well, I have to subtract the x value, and I have to subtract the y value of the current position of the center of that circle. So memorize this, and know that this is the equation of a circle located anywhere on the graph. And then you also know if it's a simplified version, or if this is 0 and this is 0, you can simplify these h's and k's and you get this. That is it. Homework for Wednesday. Alright. I'm all messed up here. No, I'm not all messed up. The problem is we were going to do lesson 76. We're going to stop right here. We're going to stop with just this lesson. So your homework for Wednesday is just going to be from one lesson, and it's from lesson 75. So that might throw people for a loop, but I'm finished talking, and we had a long scoring video, and we have a long lesson video here. We're going to save symmetry, which is fun to do. Symmetry is lesson 76. We're going to save that for Wednesday. So your homework is a little bit lighter of a load. Homework for Wednesday is just from lesson 75. Your homework is, for lesson 75, it is 1, 2, 7, 10, 13, 18, 20, 25, and 29. Please do lesson 75's homework and have that done by Wednesday. Thank you.